For decades, machines excelled at processing data inside rigid geometric grids. But human communication is different. It behaves more like a fluid, thousands of unpredictable, swirling particles of meaning and context. Before 2017, enterprise AI was highly effective at managing that rigid side of the world. It could classify millions of images or predict numerical trends within structured arrays. Yet those same systems struggled to parse the nuance and flow of unstructured human speech. They couldn't hold on to the thread of a long conversation or a complex document. An algorithm could calculate a massive spreadsheet in milliseconds, but it couldn't reliably summarize a 3-page email chain without losing the core context. This limitation began to lift in 2017, when researchers at Google published a paper titled "Attention is All You Need." That paper introduced a new type of deep learning architecture called the Transformer. This specific architecture serves as the underlying engine for nearly every modern conversational tool, from ChatGPT to Claude and Gemini. By understanding how the Transformer works, we can see how AI is finally able to index the millions of words hidden in internal documents, turning static archives into interactive resources. To understand the breakthrough, we have to look at what came before: recurrent neural networks. These models process text like a human reading a book, moving strictly left to right, one word at a time. This created a mechanical form of amnesia. Because the system processed data in a line, the mathematical representation of the first words often fades into darkness by the time the algorithm reaches the end of a long sentence. This is why older models struggled with context. If the word bank appeared at the start of a paragraph and again at the end, the model would often treat them as identical, even if one referred to a river and the other to a financial institution. Beyond this memory loss, the sequential nature of these models created a massive engineering bottleneck. Because the system had to finish word 1 before it could look at word 2, developers couldn't use the full power of modern hardware. This linear approach capped the scale of what AI could do, making it difficult to train on the massive datasets required to understand complex human language. The Transformer changed this by abandoning the line. Instead of reading left to right, it ingests an entire document all at once. Every word is processed simultaneously, and the system maps the relationship between every word in the text. This simultaneous ingestion provides a holistic view of the information. The system doesn't forget the beginning of a paragraph while reading the end, because it is looking at the entire page as a single unit. This shift also solved the engineering bottleneck that limited older models. Because the words are no longer processed in a rigid line, the workload can be split across thousands of computer chips at the exact same millisecond. This capacity for parallel processing is the reason we can now train AI on libraries of millions of books. It allowed developers to scale the technology to the level seen in today's conversational engines. By moving away from sequential processing, AI could finally utilize the full scale of modern supercomputing hardware. If a transformer ingests 50 pages at once, it needs a way to determine which words are actually relevant to one another. It manages this through a mathematical process called self-attention. Imagine an attorney reviewing a contract. They don't read every word with the same level of focus. They scan for key terms like penalty, late, or shipping, and virtually dim the irrelevant sections. The transformer does this mathematically. It assigns high attention scores to interconnected words. In this sentence, the context of approved and loan updates the meaning of bank, signaling that it refers to a financial institution. If the sentence changes to "the bank overflowed its walls," the system forms new connections. It sees the high attention score for overflow and walls and instantly knows the word bank now refers to the land by a river. Modern systems use multi-head attention to run this process dozens of times simultaneously, checking for everything from grammatical structure to emotional sentiment at the same time. This mechanism replaces rigid, pre-programmed rules with a fluid system of context mapping, allowing machines to approximate human-level comprehension. This technical shift replaces the old reliance on keyword matching with a system that understands semantic meaning. Look at how this changes search. Old systems look for exact letter matches, but a transformer understands intent, connecting housing to accommodation. Similarly, in summarization, instead of pulling random sentences, the model reads a 200-page filing and generates an original, fluid summary. In customer support, this allows systems to move beyond simple keyword triggers, like broken or angry, and instead evaluate the actual urgency and tone of a customer's request. To leverage this, organizations are moving beyond structured databases and beginning to optimize their unstructured text, emails, transcripts, and legal filings as active assets. The Transformer provides the mechanics to unify these historical archives into a single knowledge base, one that responds to the nuance of human language rather than just a search for a specific word.